In this video, we're going to talk about incidence and prevalence, both measures of disease in populations. So the first concept we'll talk about is cumulative incidence, which is a measure of the number of new cases in a given time period over the total number of individuals at risk. Anytime we talk about incidence, we're talking about the development of new cases in people who were previously free of disease. The key features of cumulative incidence are that we're looking at a given time period and in a given study population followed over this given time period. Sometimes people call cumulative incidence just incidence. Another term is attack rate or incidence proportion. Incidence is useful for identifying groups or populations at higher or lower risk for disease and for identifying changes in risk in different time periods. Incidence rate is another way of measuring incidence that looks also at the number of new cases, but accounts for the fact that there may be variable time of follow-up. And so the denominator in this case is the amount of person time at risk. Anytime you see a measure of person time, whether it's person days, person months, person years, you know that you're talking about an incidence rate. Incidence rate is also sometimes known as incidence density. There are many features that are the same as cumulative incidence. We're also looking at new cases that develop in people who are previously at risk over after a specified starting time. And again, it's a measure of disease risk. But what's different is that cumulative incidence accounts for variability in follow-up time. Advantages of using cumulative incidence over, of using incidence rate over cumulative incidence is that you can account for the fact that people can join and leave the study population at different times for a variety of reasons, and it still uses all the data that you have before departure from the study. In contrast, prevalence is a measure of the number of current cases of a condition over the total number of individuals in the population. This is at a given point in time, and a point in time doesn't have to be a second or a minute, it could be in a month or a year, but the idea is it's a static moment in time in a given population. And we use precedence for understanding disease burden in a population, which can be helpful for allocating resources. Prevalence is similar to incidence in that it's a proportion and it is a somewhat a measure of disease risk, but it's different from measures of incidence in that the numerator includes all cases of the disease, not just new cases during the period of observation, all cases that are present at the given moment in time that we define, and the denominator includes all individuals in the population, not limited to those who are at risk for the condition. So let's see how this plays out in practice. So let's say we have a population of 12 individuals in this case, and all of these people are initially at risk for developing cervical cancer. Over time, some of them will go on to develop cervical cancer. That's the red individuals. Some of the people who develop cervical cancer may die from their cervical cancer, and some people may have their cervix removed, so they're no longer at risk for developing cervical cancer. So when we're looking to measure incidence, again, as a reminder, this is the number of new cases in a given time period divided by the total number of individuals at risk for the outcome at the start of follow-up or during the observation period. We have to define our observation period. So let's say we look at a population during 10 years. Now, the first thing to note is that person number 4 developed cervical cancer before we started follow-up. And so they're no longer at risk for developing cervical cancer because they already have it. Person number 8 had their cervix removed also prior to the start of follow-up. So they're no longer at risk for developing cervical cancer because they don't have a cervix. So rather than 12 people in the population, we have 10 people. And so then we follow these 10 individuals over time, and we see that person 1 developed cervical cancer early on, person 3 developed cervical cancer a little bit later, person 7 developed cervical cancer, person 9, person 10, and person 12. This is a pretty high-risk population, actually. And then we can calculate cumulative incidence or just incidence as the 6 people who developed cervical cancer among the 10 people who were free of cervical cancer at the start of follow-up and at risk for developing it. So in this case, the cumulative incidence is 6/10, 60% in the 10-year period of follow-up. So when we think about prevalence, we have to define the moment in time in which we're interested in assessing prevalence. So remember, prevalence is a measure of current cases divided by the number of people in the population at that moment in time. So let's say we look at year 4 of our study and we're trying to define prevalence in year 4. So in this case, all 12 individuals of the original population are eligible to be included in our measurement of prevalence because we don't care whether or not they're at risk for the disease. We just want to know that they're currently in the population. So in this case, our denominator is still 12. And then the numerator includes those people who currently have cervical cancer at the time that we're doing this assessment. And so that can include person 1 who developed cervical cancer during the study period, also person 4 who previously developed cervical cancer before we started observation, defining the period of observation, but they have it, and so they're still included in this population. So in this case, the prevalence of cervical cancer is the 4 cases over the 12 people in the population at year 4, or prevalence of 33%. Now, if we look in a different year, we might calculate it a little bit differently. In this case, we have lost a few people. So 2 individuals, person 3 and person 12, died from cervical cancer, unfortunately, before they ever reached year 9. And so we're back to 10 people in the denominator. And then among those 10 people, we have person 1, person 4, person 7, and person 10 who currently have cervical cancer. So in this case, the numerator is the 4 cases over the 10 people in the population in year 9, or a prevalence of 40% in year 9. But what about the case where we're losing people to follow-up? People don't always stick around for the total duration in which we might want to see them. So for example, person 1 maybe made it, they did develop cervical cancer, we know that, but they made it to year 9, and they maybe had left the study population. Person 2 had a heart attack and died before they ever developed the outcome of interest. So we don't know if they would have developed cervical cancer or not. We do know there was some period of time in which they didn't have it, but we don't know anything about what happened after that time. Person 7 also left the study population and went away before they ever developed the outcome. So again, we just don't know anything that happened after those first 3 years of follow-up. So it's a little trickier to evaluate cumulative incidence in this case because we could just throw out those people who died or who left the study population. But we're then throwing out the information that we have about the period of time they were observed before they left. And so in this case, this is why it can be helpful to use a measure of incidence rate, in which we can use all of the new cases, but instead the denominator is the amount of person time they were at risk for developing the outcome. So how does this work? Well, first of all, we know that we have 5 new cases of cervical cancer that developed during our 10-year study period. So person 1, person 3, person 9, 10, and 12, all newly developed cervical cancer. And then what we do is we count the number of years that each of those people were at risk. So person 1 was at risk for 1 year. So they had 1 person year before they developed cancer. Person 2, even though they didn't develop the outcome, they did contribute 5 years of follow-up. And so we know they had 5 disease-free years. And so we can continue counting the person time at risk of each of those people. Again, we don't include person 4 or person 8 because they were not eligible to newly develop the disease when we defined our period of study. But all the rest of the people contributed observational time either before they developed the outcome, they maybe never developed the outcome and they had 10 disease-free years, or at least until they left the study population. So if you add up all those person years at risk, you get 55 person years, and then we would say that there are 5 cases in 55 person years, or 0.09 cases per person year. And so again, this lets us use all the available information that we have without having to throw out any data. So incidence and prevalence, even though they're calculated somewhat differently, are related concepts. So if we think about an overall population of people on the left, the empty figures that are at risk for developing cervical cancer, some of them will go on to develop cervical cancer. And then of those who develop cervical cancer, some of them will die and some of them will be cured and will no longer have disease. And so the prevalence is just a reflection of the incidence of the development of disease times the duration of disease. So if the incidence increases, if more people at risk are developing the condition, then the prevalence will go up, assuming that the people do not leave the population of those with disease. So assuming that the rates of death and the rates of cure don't change. However, if you have higher rates of death or higher rates of cure and the incidence doesn't change, the prevalence decreases. And so decreasing prevalence of a condition could be a good thing in that you're curing more people, or the incidence is lower, or it could be a bad thing in that people are dying more quickly and are living for a shorter duration of time with the condition. So hope this was helpful, and we'll post more videos on our website, and look forward to answering your questions in class. Thanks, bye-bye.